Today I released the first version of my starter template, which aims to take care of the main boilerplate code we all tend to do when building web-based games, using the canvas element. With this taken care of, it allows you to jump right into developing your awesome games without the initial hassle. In this small video, we'll explore what this is, why I created it, and what it does and doesn't cover, if people do decide they want to use it for their JavaScript gaming projects. Hi, my name is Anthony, and I welcome you to my corner of the web, where I like to build retro games within the browser using the latest technologies. Over the past several years I've been creating games for the web. I feel I've somewhat built a muscle memory into what's required for a starting point. And to be fair, I've got into a pattern of building the same thing initially over and over again for each new project, which as you can expect became repetitive. It was for this reason I decided to create a template project to house this fundamental code. Now, this is nothing new and generally considered standard practice, but having this reusable template that contains all the boilerplate code, along with some useful coding standards and utility functions, allows me to jump right into developing the actual game, without falling into the trap of necessarily using a framework such as Phaser or one of the other alternatives. I used something similar to this for my Street Fighter game, and thought it would be best to finally establish a definitive template once and for all, especially before I start any new games. I'm assuming if you've got this far into the video, you're still interested or at least intrigued. Well, you'll be glad to know that I've made this template publicly available and free for everyone. It's actually available right now from my GitHub account as shown here. The link for this will also be in the description. As the README mentions, the current version should be enough to jumpstart you into JavaScript game development, but I'll be updating and evolving it over time to cover any future needs. So to complete the video, I'll quickly run through how it works and what's included at the time of recording. Naturally though, we'll start by loading the repo first to a location on our development machine. Once complete, open it up in your code editor of choice. For reference, I'm using VS Code here. The next optional step is to pull down the npm dependencies using your package manager. This will install a small number of tools that might help you in your development environment, especially if you're using ESLint or prefer to develop using TypeScript, as it provides the basic tooling styles and rules I normally use too. Again, this step is completely optional however, so by all means go ahead and either skip this step or amend the settings to suit your own needs. Before we walk through the code, let's host and run the supplied example in the browser to see what it actually does. By default, this repo is set up to work out the box, without any build step. Although, as we're using ES modules, we will need to host the code on a web server, so that the browser can fetch the necessary files at runtime. You can set up your own build toolchain for this, but to make this step easier on ourselves, I prefer to use one of the pre-configured live server alternatives, which removes the hassle of doing so. For VS Code you can install one through the extension marketplace. Other editors have a similar option too. For myself though, the extension I've installed adds a Go Live button in the status bar at the bottom of the editor window. Clicking this will do its magic in the background, and spin up a web server to host our files on a local HTTP address. Navigating to this address in the browser now should show the following demo, an image, or sprite if you like, bouncing around the screen using the correct timing along with a piece of music playing in the background. This simple example has used the template code as its base, meaning it has to do very little to get up and running, as the template has taken care of most of the boilerplate code. Nice! If you prefer, you can now quit the video and jump right into the code, and explore what's included. But for those who want to stick around, I'll now quickly walk through the code to show you how this was achieved, hopefully providing some explanation on how this template works. Let's start with the included index.html file. As we don't require much CSS, I've included a style type that contains some basic styling for the page and the canvas element. Notice I've set the canvas to use pixelated graphics by default, so if you prefer this not to be the case, simply remove these two lines here. As for the script tags, I've also set up an input map to make our input paths in our code more consistent. One for the engine code and one for the game code. More on this soon. The other tells the browser to use modules as mentioned, and points to the index.js file in our source folder. This will be used for the entry point for our game. It also defines an image and an audio element, so that the browser will load the necessary assets for the example demo. I personally always prefer and recommend using the browser to handle the loading of assets, at least initially, as this is what it excels at. We can always dynamically load them using code at a later date if need be. And finally, I've also included a web font so that drawing any text will be consistent across browsers. We'll move over to the initial code file now, the index.js file. This imports the main extended game class called template_example from the game folder and calls its start function. This ultimately sets our main game loop in motion. You'll also notice we have two folders here too, matching the input map in the HTML file. The engine folder houses all the template code, such as the base classes and helper functions. Basically, it provides all the code to set up and configure the browser, the canvas, and the main loop for our games. The actual example code lives inside the game folder. It's designed this way to keep your template code and your game code separate. Opening up the game folder, we have a number of other folders inside, which group the various code files into their corresponding parts. Config for configuration settings, constants for reusable constant values, entities for all our moving objects we'll use in our game, and scenes, which is basically a container for a section of the game, and will house the bulk of our draw and update calls. This is my preferred way to structure my game code, but please go ahead and do your own thing if you choose. Next, we'll open up the template example file. Notice how this class extends the engine's game class. The game class contains everything you'll need for the initial configuration and setup of your game and canvas, so this should always be used for the initial class. For that reason, we really only need to do two things here. Supply the first scene class we'll be using, and call the superconstructor function with the necessary details to set up the canvas. The supercall requires a CSS selector defining where you'd like the canvas to live inside the DOM. Generally, this is always the body element, but the option is there if you wish to move it elsewhere, along with a width and height dimension for its size. I've added two constants to the game constant file to hold these values, as we'll be using them in other files. As for the initial scene, we've called that test scene and is strangely available in the scenes folder. So let's go ahead and open that class next. Ultimately, a scene sets up the world where your entities will live, which is exactly what we're doing here. We start by retrieving a reference to the assets we defined in the HTML file, and then in the constructor, creating a new logo entity by creating a new instance of the logo class, passing on its starting and X and Y position. More on entities in a moment though. Underneath this, we call the template's play sound helper function to play the music. Looking at the bottom of the class for a moment and ignoring the code in the middle, we have the main, update and draw functions. These functions are mandatory for each scene, as the game's main loop will look to run both of them on every frame. To explain why, the update function is used to update the game's logic for each frame. For example, an entity's animation or movement. In this example, we're updating the camera, the logo entity, and the lightness variable. This function also supplies a time variable. This is the frame time counter and can be used to accommodate consistent updates based on time between frames. Likewise, the draw function will draw the game's visuals to the canvas based on the updates in each frame. This function will have access to the canvas context, which you can use in this function or preferably pass on to other required calls or entities. For example, in this scene, we're clearing the background, drawing the logo image, the border, and the text message using the imported font. This is again generally standard practice in game engines, so it's something I followed in my template. Hopefully if you follow my Street Fighter tutorial, most of this should be familiar, and if not, I've included a link in the top corner so you can. I generally like to keep my code clean, so I extract any distinct update and draw calls into their own functions, which is what most of the code in the middle is. And finally, just for completeness, we'll have a look at the logo entity class, which we're importing from the entities folder. This class simply houses the movement and drawing functions for the logo that bounces around the screen. It uses the screen and image dimensions to confine it, changing its velocity as it hits the edges of the screen. Notice how the entity classes also follow the same structure and format as the scene class, adding a reference to the image asset from the HTML file and using the main, update and draw functions. Again, these are mandatory just in the same way as that class too. The only other required thing to note about entities is its position object, passed into the constructor. This is the entity's starting position, which if we refer back to the test scene class, we pass on the X and Y position. And that's all there is to it really. I hand the baton over to you I guess. The example code was made to give people a simple springboard to expand upon and play with, so why not poke around and have a play with the code and see what you can make of it. In regard to the template code, it's still early days, and it'll probably keep improving as I develop more games with it. This probably won't go in the direction of a framework however, as there's plenty of those out there in the wild already. But if you have any suggestions on what you'd like to see from this, such as other useful utility functions that could be added, then please drop me a message in the chat and let me know. As for my gaming tutorials, I'll be using this template as a starting point for all of them too, starting with my Bomberman series next month. This should give us all a constant starting point, so that we can jump straight into the game code. Speaking of which, I have many ideas for future game series now that I have this in place, but I'm getting ahead of myself again. There's plenty of time for those in other videos. Thanks for everyone's support and thanks for watching. Ant out.